Hi guys, welcome. We are looking at day 20 today, and we're just looking at lesson 63. So the concepts that'll be covered today: rational numbers, non-terminating decimals, and percents, fractions with negative exponents. So a lot of concepts we'll be covering. So if we're looking at terminating and non-terminating decimals, again, if it can be written as a fraction, then it's still a rational number. So like 1/3 becomes 0.3 repeating forever. Even though it's repeating forever, it's still rational because we can express it as a fraction. If it continues on forever and is non-terminating or non-repeating, that's when it becomes irrational, but we wouldn't be able to represent it in fraction form. So 1/8 becomes 0.125, 1/11, 1/11 becomes 0.09090909, so it's repeating. So we put the bar over the 0 and the 9 because both of those values are repeating infinitely. Express 2/3 as an equivalent decimal and percent, and express 2/3 as a decimal rounded to the thousandths place. So we know 2 divided by 3 gives us 0.666 repeating forever. So it's 0.6 with the bar above it. Okay, we want to make that into a percent. So we do 2/3, okay, which is our fraction, times 100, which gives us 2 times 100, which is 200, divided by 3. 3 goes into 266 times, which is 198. So we have 2 left over, and it's being divided by 3. So 66 2/3%, or I'm okay, since we've talked about how, okay, so 0.6 repeating forever. We've talked about how to convert decimals to percent. So I'm okay if you use 66 2/3% or 66.6 repeating percent. So I'll show you what I mean. So we have 60, continue on forever. We know to make it a percent, we're multiplying by 100. They just showed us how to multiply the fraction by 100, or we can multiply the decimal by 100, which is just moving it 2 places to the right. Same thing with any value. So we get 66 now, and then 0.6 repeating forever. So if it's a test question and you get something like this, don't call it 66%, don't call it 67%. Okay, call it 66.6 repeating forever, or the way they did 66 2/3%. For me, anytime we're talking about percent, I see a fraction, it kind of, is it a mixed number, or is that the fraction, or is that the percent, or is that a fraction? And I think it's very easy to convert from decimal to percent and percents to decimal. So I'm okay if you do it this way and call it this value, or do it the way that they showed and call it this value, since these two are exactly the same. We're not rounding this because it is repeating forever. Either one of those would be acceptable to me, unless it says specifically write it as a decimal or as a mixed number. Okay, and then if we round it, okay, we want to round it to the thousandths place. So 3 decimals, we go 1, 2, 3. The value to the right obviously is 6 because it's repeating forever. So 5, 6, 7, 8, 9, we round up. So it becomes 0.667. If you do in your calculator, that's a good point, because if we do 2 divided by 3 in our calculator, hit enter, we get 0.666666667. Okay, that doesn't mean that it becomes 7. That's just our calculator rounding it off. It automatically rounds after, what do we have? 1, 2, 3, 10 decimal places. So it rounds to the nearest 10 decimal places. So we have that set up in our calculator. So that doesn't mean it becomes 7 all of a sudden. It's just that's our calculator rounding it. So just be aware of that. Okay, if we do 16 2/3, that's our percent. We want to work back to a fraction. Well, 16 2/3, we're dividing by 100. This would be 16.6 repeating forever. So again, we could do the decimal and then move it 2 places to the left, or if we have a fraction, okay, we get 16 2/3 divided by 100. This is a complex fraction, so we need to make our mixed number a improper fraction. Dividing by 100, okay, divided by 100 is the same as multiplying by the reciprocal. So we get 50/3 times 1/100, because we're dividing by 100 is the same as multiplying by 1/100. And 50 goes into 50 once and into 100 two times, or 1 times 1 is 1, 3 times 2 is 6, so it's 1/6. Okay. If we're looking at fractions, percents, and decimals and comparing them, I would get them all in the same form, either all as decimals, fractions, or percents. So then you can compare them. Probably the easiest, 4 divided by 5 is 0.8. Okay, 83 and a third is 83.3, repeating forever. So we move the decimal to the left, 0.833333, and then 0.83 would be zeros afterwards. Then once we have that, we can compare. This is our largest value, so it'd be all the way to the right. This would be in the middle, okay, and then 4/5 is just 0.800, so that would be our smallest value. Once we have them all in the same form, we can look, well, the ones values are all zeros. That doesn't help us. The tenths place are all eights. That doesn't help us. The hundredths place 0, 3, 3. Okay, well, I know 0 is less than 3 and 3, so this is my smallest. Then looking at these two, 3 and 3, then go to the thousands place, 3 and 0. Well, 3 is greater than 0. So I know this is my smallest, this is my middle, and this is my largest. That's a way to compare them. Okay, looking at negative exponents. So if I have a negative exponent, this is on your reference sheet, it's the same as 1 over that base to that positive exponent. So if I have 2 to the power of negative 2, well, this doesn't make it -4 or anything like that. This negative exponent doesn't mean that the answer is going to be negative. What this is equivalent to, I take the reciprocal and then I make this -2 a positive 2. And you can do this in your calculator. If you did 2, hit the up arrow, and then did -2 for your exponent. So we do 2 to the power of -2, we get 0.25. Okay, and that's a positive number. It's just gotten smaller. It's less than 1 because it's equivalent to 1 over 2 squared, which is 1 over 4, which is 1/4 or equals 0.25 in decimal form. Okay, so it's a reciprocal. 2 to the -2 is 1/4 because 2 squared is 4. Okay, so just think of reciprocals when you do this. So don't let that negative symbol throw you for a loop. So if you have x to the power of -n, that becomes 1 over x to the power of positive n. So if we have 1/3 to the -2, and it's all of this, and it's a parentheses, so everything inside here we're doing to the -2. So we could rewrite this as 1 to the power of -2 over 3 to the power of -2. Okay, or this is 1 over 1 squared times, okay, this would be 3 squared over 1 because it's in the denominator, now it's in the numerator. This is just 1 over 1 times 1, which is 1 over 1, which is just 1 times 3 squared over 1, which equals 9. 9. Okay. So again, the reciprocal 1/3 becomes 3 over 1 times 3 over 1, because that would be the reciprocal to the positive exponent, and that just equals 9. Again, you can put those, just make sure you put the fraction in correctly, use your parentheses if you're doing it with division in your calculator, and it'll do it for you. That negative exponent doesn't mean it becomes 1/3 squared and then we make the solution negative. No, it's the reciprocal. So 1 over 3 becomes 3 over 1, or just 3. So just think reciprocal in this case. Okay, and this rule, I believe all this, it's on the algebraic sheet that has all of these rules in there. They may use A and B and C or MXN or something like that, but it'll have the same concepts in there. So if I have a fraction raised to a negative exponent, I do the reciprocal and then raise it to the positive exponent. Same concept we just talked about right here. Okay. I think, yep. All right, just 63 today. So we'll do these practice set problems together. When we get to class, make sure you guys feel comfortable with that. Know where to find it on your reference sheets. And if you're drawing a blank on a test and you have that reference sheet, it'll help you figure out what these rules are. If you don't, then you're just trying to hopefully remember it when you're taking the test, which I know may not always happen. So have those handy with you as you take the test. All right. We'll see you guys here in a couple days.